Hello everyone, and I welcome you all in this learning video where we are going to discuss now on problem of continuous random variable for conditional distribution. Okay, so let us see this what this problem says. Here the if you are not able to identify whether the problem is of discrete or random variable, discrete or continuous random variable, you just look at the terminologies. In the discrete random variable, we will be having the probability function. Here we'll be having the joint density function. So that is the difference we have. Okay, and sometimes here the values are explicitly given to you, sometimes range will be given to you. So what is the meaning of x greater than equal to 0? So it is like 0 less than x less than infinity, and for y greater than equal to 0 it would be like 0 less than equal to y less than infinity. Okay, so these are the things we have. So how to start with? We are given a function, joint density function, and we have to find out the conditional density function of x given by and y given x. Actually that is not the question. The question is actually that is the only question that we have to find out, because whether it is given or not, that marginal, you have to find out marginal density function of x and y. But if you find out, if you go for finding out the conditional density function of x and x given y or y given x, you have to find out the marginal density function. So whether it is given in the problem or not, you have to find out the marginal density function. So let us find out first of all the marginal density function. So number one, the marginal density function, the marginal density function of x is, what is the marginal density function? It is denoted by f1 of x, and it is given by integral minus infinity to infinity f of xy dy. It is actually y is equal to minus infinity to infinity f of xy dy. But we have the value of this function from 0 to infinity. So you can break the interval minus infinity to 0, 0 to infinity. But from minus infinity to 0 we don't have anything. So we have to start like this. Okay. So integration 0 to infinity, of course y equal to 0 to infinity. Why we are taking only y equal to 0 to infinity? Because we have the value for y equal to y onwards, we have the value. So this is e to the power minus x into e to the power minus y dy. So I am writing e to the power minus of x plus y is minus of x minus of y. Okay. Now let us integrate it. So e to the power minus x is constant. Integration of e to the power minus y is e to the power minus y divided by the coefficient of y, that is minus 1, limit 0 to infinity. So this is like e to the power minus x into e to the power minus y infinity to 0. So what is it? This is e to the power minus x, e to the power 0 is 1, minus e to the power infinity, minus e to the power minus infinity is, e to the power minus infinity is 0. So we have e to the power minus x as my f1 of x. If you want to write it precisely, you can write that is marginal density function of x is e to the power minus x for the range. What is the range we have? For x greater than equal to 0, and for x less than 0 we have value to be 0. Okay. Now we got the marginal density function of x. So once you get the marginal density function of x, you can easily find out the marginal density function of y given x. You can easily find out this. Therefore, the conditional density function of y given x is, what is it? Conditional probability of y given x is equal to f of xy upon f1 of x, and we have these values Okay, so we have these values. Substitute what is f of xy? E to the power minus x into e to the power minus y upon what is f1 of x? Just we have got the value minus x for x greater than equal to 0, and for x less than equal to 0 we have 0. So this get cancelled, and this is your conditional density function of x given y. Okay, now you can follow the same method to get the conditional density function of x given y. And to find out x given y, what we need to find out? You need to find out marginal density function of y. Okay, so what is marginal density function of y? It is denoted by f2 of y, and is given for x is equal to minus infinity to infinity this. So this is x is equal to 0. Just take e to the power minus y common, integration of e to the power x is this, apply the limits, and you'll be getting e to the power minus y. That is my marginal density function of y. So write down its general form. So this is minus y for y greater than equal to 0, and this is 0 for y less than 0. Therefore the conditional density function of, what is it now? Now this x given y is f of x by y, or we read it as f of conditional density function of x given y is f of xy upon f2 of y. So it is like e to the power minus xy, e to the power minus y for y greater than equal to 0, and for y less than 0 we have this get cancelled. So we remain with e to the power minus x. So I hope you got the idea how to find out the marginal density functions of x and y, and also the conditional density function of x and y. Okay, so it is just like buy one get one offer, like, okay. So thank you for watching this learning video. If you have any suggestion regarding the topics that we have covered, you can write in the comment section to make it more better for you. Okay, so thank you for watching this learning video. Enjoy learning mathematics. Thank you.